Emostel.
Hello, this is Emmanuel Kadiri, and you are welcome to Emostel Academy. In this video, we'll be talking about the topic factorization. All right, factorization seems to be the reverse or the opposite of expansion. So when we expand the bracket or we do anything of such, we seem to resort to some kind of expression that is wide or that is just full. But when we factorize, okay, the expression that we do the reverse of the case, and the expression seems to go back to its compact form. Now, another thing again that you should take note of is that expansion deals with more of multiplication and addition and all that. But factorization deals more with division. So when you multiply in expansion, you divide in factorization. Expansion will lead to a wider scope of terms. It leads to creation of more terms for an expression. But factorization will make it more compact. That is, we just have only a few terms per expression. So we are going to see all of this as we move into these examples. All right, enjoy with me. We have x squared plus 2x, for instance. All right, so x squared plus 2x. So the next thing that you should look for, whenever you have something like this, just look for a term, a factor that is common to the two terms. There is something that the two terms have in common, although they are not related, they are not family, okay? Which means that this one, although both of them have x, but they cannot add or subtract each other because this one is x that has a power, and this one is an x that is multiplying a number. Okay, so they cannot add or subtract each other, but you can do something about them in order to, to make it more compact, and that something is factorization. How you carry out factorization in this kind of case is when you just look for a number that is common, a factor that is common to the two sides or to the terms involved. So if you look at it, you will see that x can divide here, and x can also divide this term, which means x can go in it. You can use x to divide this term without remainder. You can also use x to divide this term without a remainder, okay? And so, let's see. So, which means x is common. X can go here, x can go here. X can divide this number, x can divide this, and x can divide this term, and x can also divide this term and give us a result without remainder. And so, we choose x as the common factor. Is that clear to you? Now, since we have been able to get a common factor, we use that common factor to divide each term and then collect the results in a bracket. I know this might be confusing, but just watch how I do it, okay? So now when we consider the first term here is what? The first term is x squared, x raised to the power 2. X raised to the power 2, when you divide it by this one out here, divided by x, okay? X raised to the power 2 divided by x will give us x. X raised to the power 2 divided by x means, it simply means x times x. That's what it means, x times x. Then when you divide it by what? X. This will take 1 and it will be remaining 1x. So that's 1x that is the result, is what you keep in the bracket here. I believe you get that? Good. So then we have plus x, okay? So plus 2x. Plus 2x, you divide it by this term, this common factor, which is x, okay? So x goes here 1, x goes here, x cancels x, it's remaining plus 2. So this plus 2, you write it here, and that is the answer. So you have been able to factorize x squared plus 2x into x into bracket x plus 2. If you want to get this result back, you expand. For instance, if you expand, you say x times x will give you x squared, and you say x times plus 2 will give you plus 2x, which is the same thing as what we have here. So this is the expanded form. This is the factorized form. By the time you expand it, you go back to this form again. So that's how it just works. They are opposites. So in expansion, you multiply, just the same way we multiply this by x, also multiply this by x. But in factorization, you divide. You divide this by x to get this, and you also divide this second one by x to get this. So that's how it goes. So the opposite is the opposite of expansion is factorization, and so that is that as per that. Okay, so I don't want to confuse you, so I'm going to rub up this part. So let's check out this second one. We have 6 minus 3y. Okay, good. Though they cannot add nor subtract. So, but they can, something can be done because they have something in common. If you check it very well, 3 can divide 6, and 3 can also divide minus 3y, effectively without a remainder. Okay, so because 3 can go here, 3 can go here, and then we make 3 the common factor. But apart from 3, in terms of letters, nothing else is common. In terms of letters, nothing else is common. Only numbers are common. Okay, so since there is no here now, x is common, okay, but no number is common except 1. 1 is a general common factor, so we don't always consider it when we want to do this kind of thing. So it's just general because it's always there. It will still give us the same value, the same result. So we just let it be. But from 2 and above, and from any letter, we put them into the factor. Okay, good. So now we have 6 minus 3y. 6 minus 3y. 2 can divide 6 very well. When 2 divides 6, we'll get 3 as a result. But 2 cannot divide 3y. So because of that, they don't have anything in common. Okay, because of that, 2 is not common. Okay, so now we look for the next common factor. In terms of letter, y can go here, but y cannot go here. Y can divide minus 3y, but it cannot divide 6 without remainder. Okay, you cannot divide 6. So we look for the next thing that can happen. Since we are so sure that the letter y cannot be a common factor because it can only work here, but it can't work here, so we let it go. So which means we are not considering any letter as a common factor. Then let us look into a number. Okay, we cannot use 2. 2 can go in 6, but it cannot work here. So then the next thing we look into is 3. Yes, 3 can divide 6 and 3 can divide minus 3y. So it means 3 is a common factor. So if 3 can divide both, and then we bring it out. So we open the brackets. Now, 3 divides 6, okay, to give us 2. That is, 6 divided by 3 gives us 2. Then minus 3y divided by 3 will give us minus y. How did that happen? Okay, if you say minus 3y divided by 3, okay, 3 cancels 3, so we still have the minus and the y, so we have minus y there, and like that, you get? So that's the answer. If you expand it, you're going to get this back. Like 3 times 2 will give you 6, 3 times minus y will give you minus 3y. Okay, so this is the factorized form, and this is the expanded form. You get that? Good. So number 3 says minus 2 minus 2x plus 2y. As you can see, looking at this picture directly, okay, you will see that 2 is common to everything there. 2 can work here, 2 can divide this term, it can divide this term, it can divide this term. So 2 is a common factor across all the terms. But apart from 2, nothing else is common, because x can only divide here, it cannot divide this term, it cannot divide this term. Y can divide this term, y cannot divide here, y cannot divide here. So 2 is a common factor. So, but then you have, just bring it out as minus 2. Oh, sorry. If you use 2, only 2, you're going to be having something like this. I just want to show you something here now. If you use only 2, so you'll be having minus 1, because 2 divided by minus 2. So let me just do it this way, that way, the same way. Minus 2 divided by 2. Okay, this is like a positive 2. So minus divided by plus will give you minus. Okay, so 2 cancels 2. That's 2 divided by 2 will give you 1. This one says minus 2x. Minus 2x divided by these 2 out there will give us here plus divided, this minus, then we have x left. Okay, then we have plus 2y divided by 2. Plus divided by plus is plus. Okay, and then 2 cuts out 2, then we have y. So we have plus y remaining. Okay, but in mathematics, this is not ideal. This is not ideal. You can rearrange it, but it's not ideal. It's not like it's not possible, but it's not ideal to have a negative number as the first number in the brackets and you leave it like that as your final answer. Okay? It's not ideal to do such. So what you do, you can either arrange it. You can say 2, open the bracket, you put this one, like you put the positive one, y, and then you can say y minus x minus 1. This is permitted. It's correct. So you can, if you expand it, 2 times y will give you 2y. 2 times minus x will give you minus 2x. 2 times minus 1 will give you minus 2. Okay? So you are still doing the same thing. You are still on track, but it is ideal to write it this way. We don't really like keeping negative number as the first number inside the bracket when it is to be written in its factorized form. Okay? So you can keep the answer like this. You can also do something like this by you could also try another way you can get your answer or factorize this. Okay, you can just make negative 2 to be a common factor. Since we have minus 2, and plus 2, okay, you can make negative 2 be a common factor, no problem. If you make negative 2 a common factor, so you are going to have negative 2, you open the bracket, then, so you have it like this. So you do use this negative 2 to divide each of the 10. You have negative 2 divided by negative 2. So this cancels this, becomes positive, 2 here, 1, 2 here, 1. So we have 1. Okay, 1 divided by 1 gives you 1. So that's 1. And then pick on the second one, minus 2x. We have minus 2x divided by the negative 2 outside. So this negative 2 will divide each of the 10. Okay? Because we picked it out as the common factor. It's all good. Okay? So then we have minus 2x. So minus divided by minus gives us positive. 2 cancels out 2, then it remains x. So you have plus x. Then this is plus 2y. Plus 2y is like plus 2y divided by negative 2. So plus divided by minus is minus. And then this cancels out this. You have what? You have y. So this is also a very good answer. A very good answer. Because if you expand it, you get this thing back. So the answer comes in different form depending on how you have chosen to expand, to factorize it. Now, on this expansion state, now, minus 2 times 1 will give us minus 2. So minus times plus is minus, 2 times x to give us 2x. Then minus times minus is plus, 2 times y gives us 2y. So this answer is correct mathematically. This answer is also mathematically correct. Okay? Do you still want to see another way it can come? All right, let me show you again. Another way this answer can appear, okay, let's just say or, is by grouping them. You can factorize by grouping, okay? So we have minus 2, okay? Minus 2 minus 2x plus 2y. We can decide to group these parts. Let's just group these parts and leave the other part out. So from this first group, what is common? 2 is common, or minus 2 is common. So we open the bracket, say minus 2. Okay, so minus 2 open bracket. We now use this minus 2 to divide each of the 10 inside this square bracket. Okay, because we group them. So this is just a group. We decided to leave this guy out and group them. So in the grouping, okay, in the grouping, we have minus 2 divided by this first term here, divided by this minus 2. So minus divided by minus is positive. So 2 divided by 2 is 1. So we have positive 1. Then minus 2x again. So we have minus 2x divided by minus 2. Minus divided by minus is plus. Okay, 2 cancels this, it remains x. And then you write this one out, plus 2y. So this is also another way to write the answer, because at this point now there's nothing we can do. Okay, and then we could as well write the group it the other way around. That is, instead of grouping it from here, we can group it the other side. Okay, so let's have it. The question says minus 2, this to another alternative, minus 2 minus 2x, and then plus 2y. So instead of grouping it from here, let's group it towards the right. So we have minus 2 standing out. We now group the other one as minus 2x plus 2y. Okay, so we just pick out this group. Remember that the minus sign belongs to this. Okay, in the grouping process, we will not leave out that factor. Okay, so this minus 2x, then plus 2y. So in that group, what is common? Okay, let's pick it this way. Okay, we have minus 2. All right, so what is common here? You can write this one out and then check out the common factor in the group, because at the end of the day, the minus will still even affect it. So let's work it out this way. Sorry, let's do it this way. Okay, the way I did it earlier. All right, so let's go. So in the group, in the first group, what is common? Let's say minus is common, because whenever we have minus as the first number, as the first term, it is always good to consider that minus as a common factor. When we have a negative number in the first term, it is also always good to consider minus as as one of the common factors. Then we look out for the other common factors. Well, in terms of numbers, what is common? 2 can go here, 2 can go here, so 2 is common. Then in terms of letters, nothing is common. Okay, so x can go here, but it cannot go here. Y can divide here, but cannot divide here. So, but in terms of signs, so whenever you are considering your common factor, consider it in this pattern. S, N, and L. S, N, L. You first consider the sign, you consider the number, and you consider the letter. Okay, S, N, L. Okay, first check what is common in terms of sign. Whenever the first term is a negative number, then minus is considered as a common factor. So you write it out, minus. Then the next thing, in terms of number, what is common to these two terms? In terms of number, what is common to these two terms is 2. 2 can divide here, 2 can divide here, okay, without remainder. So you write, that's why we wrote 2 here. So minus is common, you write minus, we wrote minus. Forget about the fact that this one is plus. Once the sign of the first term is negative, okay, it is ideal to consider minus as a common factor when that kind of scenario happens, okay? All right, so minus is the common factor in terms of sign. Then the common factor in terms of number is 2. So what is common in terms of letter? Nothing, so you leave it out. Then you open your brackets. So when you open your brackets, what comes next? We use this minus 2 to divide these two stuffs. So we have minus 2x divided by minus 2, okay, right? Minus divided by minus is plus, that's positive. Then 2 cancels 2, which remains x, all right? And then plus 2y as well, plus 2y divided by minus 2. Plus divided by minus is minus, then 2 cancels 2, so we have y remaining. So we have it this way. Okay, so which means that by the time we consider the grouping from this other side, this is the result of the factorization. And then the next thing is to remove the bracket. Just this one is not a multiplying bracket, it's just a separator bracket. So this one is not multiplying anything. Okay, we just only use it to separate this group from this. Okay, so we are going to remove it, and then we have minus 2, okay, minus 2 into x minus y. Minus 2 into x minus y. All right, and so you leave it this way. I know you're looking at this one and this one, right? You cannot, it will be a mathematical blunder to decide to factorize here, because this 2 is not standing alone. The 2 is attached to a bracket. The 2 that you are seeing here, the minus 2 here, is attached to a bracket. If it was standing alone, you are very free. Maybe there was a plus in between. No problem, it's free. Then it's not considered to be attached to the bracket. It's considered standing alone. Then the two of them can interact in terms of factorization. But in this case, the 2 is attached to the bracket. So it is just, it cannot function with these 2 here. All right? So you just leave it that way. Remember this question? It's part of the questions we solved when we started expansion. And so that's how it goes. Okay? So that is the end of that question. So you see only one question appearing, only one question having different forms of answers. I think it's one of the forms that looks like the question we solved earlier during the process of expansion, okay, which is the last form. But all the form in which it appears, they are all the same. They are all mathematically acceptable. I only try to show you all the possibilities because there will be some aspects of mathematics, okay, where you would need to apply any form of the possibilities. For instance, you are solving a question and the question is objective, like multi-choice question. And then after you solve your question, the answer you got is different from the answer in the multi-choice. So it won't affect you. You know, you will easily be able to, like, okay, let me see why the answer is appearing this way. My own answer appears this way, but I did what is correct. I did what is right, which means you are correct too. But it is only one of all the possibilities of the appearance of that answer that is appearing in the options. So this skill or this knowledge will help you in that case. Okay, you knowing fully well that, okay, fine, you got it right, then you just check which of the what is in the option. Then when you look at the options available, it tells you how you can adjust your answer to get the particular one that was used in the option. Okay, take for instance this same question, you came across it in the examination and you were asked to factorize. Maybe after you factorized, you got this answer, but you got this answer right, but this is not appearing in the option. Okay, so the knowledge that you have gathered here will help you to know how to manipulate it again in order to get an answer that fits into the one available in the option. So as you have it here now, you have learned how to adjust it. Okay, maybe this is what I got and this is what is in the option. You say you are still correct. All you just need to do is to rearrange it. So when you rearrange it and you check the option again, you will see that this particular option will be there. Okay, let's assume you have done the whole thing and this option is not there. Okay, you will still give up, knowing fully well that you did what is right. Okay, you will still do further adjustments. Maybe you factorize by grouping and then to get this kind of answer. So if you factorize by grouping and you got this kind of answer, it's still not in the option, then try the other grouping to get this answer. In as much as you are doing what is right, there is no how that one of your answers will not coincide with what is available in the option. So that is why I kind of have to teach you all the possibilities so you don't get stranded when you solve a question and you don't find the answer the way you want it. All right, so that's that. It's getting interesting, I believe. All right, so let's move on to question number 4. Question number 4 says 4x cubed minus 2x squared. As you have this question, okay, in terms of signs, okay, because the first term that you have is a positive term, so no problem. Don't introduce minus as a common factor. It is ideal to introduce minus as a common factor when the first term is negative. But here, the first term is positive, so leave it that way. So which means positive is a common factor here in terms of sign. Then in terms of number, what is common? if you check, 2 can divide 4 and 2 can divide 2, right? So good. So then you have it this way, 2 as a common factor in terms of number. What else is common? In terms of letter, x can divide, right? X can divide both sides because x can go in x cubed, x can also go in x squared. But we always like to go for the highest common factor. We like to go for the highest common factor. I believe you get what I'm trying to say. Yes, x is common. X can go here and here. But something higher than x can also still go in the two of them, which is x squared. Okay? So we have x squared, we have x cubed, we have x raised to the power 4, and so on and so forth. Okay, fine. The lowest common factor is x. X can divide here, x can divide here. As a matter of fact, when you divide x cubed by x, you get x squared. Okay? When you divide x squared by x, you get what? You get x. Okay? So you get x raised to the power 1, which is x. All right? So, but x will still be remaining. We want the thing to appear in its lowest common factor. And we want the factorization to just appear in a manner that, yes, this is the lowest way. Nothing can be further factorized. Because if you use x as a common factor, all right? If you use x as a common factor and you open the brackets, okay, you're going to have 4x cubed divided by 2x, right? So 2 here cancel 2 in 4, that will be 2, okay? Then x here 1. How many x can go in x cubed? It can go once, which is remaining x squared. That is, x cubed means x times x times x. When you divide it by 1x, okay, this it will still remaining 2 x's, right? So that's why we have x squared. So we have x squared, all right? So 4 divided by 2 give us 2. Then x cubed divided by x give us x squared. Then minus, you have 2x squared. When you divide 2x squared by 2x, you always use the common factor to divide each of the terms. So when you divide 2x squared by 2x, 2 cancels 2, okay, no problem. Then, minus 2x, okay, plus divided by minus is minus. And then 2 cancels 2, so we have x and x squared here, okay? X squared means x times x. So when you divide it by x, so you have x cancels x, to remain 1x. So you cannot call this a complete factorized form because you are still having a common factor here, which is x. Okay? So this is not mathematically acceptable as your final answer. So because something is still common, okay, to the terms inside the bracket, you will still need to further factorize. So that is the reason why whenever we are looking for the common factor, we go for the highest common factor. It is true that x can go here and x can go here, but another thing higher than x can still go, which is what? X squared. X squared can divide here, x squared can also divide here successfully without remainder. So we consider that as the common factor. So we have 2x, then 2x squared minus x. Okay. So we have this 2x here. Now this 4x cubed, okay, then this is 2x. In terms of numbers, in terms of sign, positive goes. In terms of numbers, 2 can go here, 2 can go here. In terms of letters, x squared can go here, and then x squared can go here too, as the highest common factor. So we are going to consider that. So we put it 2x squared, all right, 2x squared, then is 4x cubed divided by 2x squared. So 4x cubed divided by 2x squared. This 2x squared here, use it to divide each of the two terms. Now, we are dealing with this one first, 4x cubed, then divided by 2x squared, okay? 2 here 1, 2 here 2, all right? So we have 2. Then x squared, then x. Let me tell you, because x cubed means x times x times x, and x squared means x times x. So when you take 2 out of 3, it remains only 1, okay? And so that's why we have it here as x. I hope you understand that. X raised to the power 3 means x times x times x. X raised to the power 2 means x times x. So when you take 2 out of the 3, it should be remaining 1x, which is what we wrote here. And then, with the 2 that we had here earlier. So that's how we have 2x. Okay, good. So when you come to this next term, the next term is minus 2x. Minus 2x, you divide it by positive 2x squared. Minus 2x squared divided by positive 2x squared. Plus divided by minus is minus. This cancels this, right? So we remove 2x's out of 2x's, nothing is left. So that is what? 1. Okay, that's 1. 2x squared divided by 2x squared is 1. When the same thing divides itself, the result is 1. Okay, so but plus divided by minus is minus. 2x squared divided by 2x squared is what? Is 1. All right, and so if you look at the bracket here now, you see that nothing is common anymore. Look at the bracket here too. Nothing was common anymore. Nothing was common here. Nothing common here. Nothing common here. But if you finish factorizing and the content of the bracket still have common factors, it means you did not make use of the highest common factor. That's what it means. So when you have 2x squared and minus this, so this is the final answer. If you want to get this result back, just multiply. Okay, 2 times 2 will give you 4. X squared times x will give you x cubed. Okay, positive times negative is negative. Okay, that's plus times minus is minus. Different signs, minus. Then we have 2x squared times 1 gives you 2x squared. So it's as easy as that. Okay, so when you are breaking it down, you divide. When you want to take it back up, you multiply. That is how it goes. The idea of this common factor is very important. I mean, the highest common factor for that matter, not just the ordinary common factor. Okay? All right, good. Well, let's look at question number 5. Question 5 says, oh, is it 5 or 6? 3, 4, okay. Question number 5. Question number 5 says, x squared y plus 2xy squared. X squared y plus 2xy squared. The very first thing you do here too, just like we are doing, you check in terms of signs, what is common. Positive is common because the first term is positive. If the first term was negative, then minus would be the common factor, like it happened here, okay? So we have x squared plus xy squared, okay? Good. So x squared, what is common to the two terms? In terms of letters, positive is common. In terms of number, signs, positive is common. But in terms of number, what is common? Only 1 is common because 1 can go in everything, right? Fine, but it's always invisible. But 2 can go here, but 2 cannot go here, so no other number is common. Let's consider letters. In terms of letters, x can go here, x can divide something here, and x can divide something here without remainder, okay? And then y can also divide something here, and y can also divide something here without remainder. But apart from x, single x, and single y, okay, we can x squared is not common because x squared can go here, but x squared cannot go here because the next number is lower than x squared. Okay, so you cannot divide. So let's go for the highest letter that can divide, and which is x and y. So we have xy. I'm going to teach you another method of getting this anyway. So of getting the common factors. So we have xy, okay, open the brackets. Now, because in terms of letters, x is common. X can go here, x can go here without remainder. Y can divide here, y can divide something here too without remainder. So we bring the two of them out as xy. So we use this xy to divide the two sides. So we have x squared y divided by xy, okay? All right, so y cancels y. So y is gone. Then out of the two x's, this x will cancel one of it, so to remain 1. We write the remainder. All right, then plus 2xy squared divided by xy. Plus divided by plus is plus. Then x cancels x, y here 1. Y will cancel 1 out of the two y's in the square. Okay, so it will remain 1y. So we have plus 2y. We write plus 2y. Okay, and this is the final answer. If you check it out, nothing is common again in the brackets, so we are good to go. And so if you want to get this stuff back, just multiply what you have here. Just say xy multiplied by x will give you x squared y. And then xy multiplied by 2y will give you 2 x squared, then y times y will give you what? Sorry, it will give you 2x, then y squared coming from y times y. If you expand it, you know, just do the normal expansion, this times this times this, you get this result back, okay? And so that is how it goes. I believe you are getting me, okay? Number 6, if you don't understand any part of this, please feel free to send us a mail, or you add you send a WhatsApp message. Sorry. Okay. Now number 6. Number 6 is like this: 3x plus 9xy minus 12. To solve this question, you know, we can just look for the common factor in terms of numbers. In terms of number, 3 is common, okay? So we have 3 can go here, 3 can go here, 3 can go here. So we have 3. In terms of letters, nothing else is common, because x can go here, x can go here, but x cannot go here. Okay, so you open the brackets and then say 3x plus 9xy. Okay, just 3x divided by 3 to remain x, okay, plus 9xy divided by 3, okay, plus divided by plus is still the same plus. So 3, that's 3, 9, that will give you 3, okay, nothing more is dividing, so you write out sy, then minus 12 divided by 3, okay, that's 4, okay, so you have minus 12, that's minus 4, and that's it. If you expand, you are going to get this thing back. 3 times x will give you 3x, then plus 3 times xy will give you 3 times 3, that's 9xy, and then 3 times 4, 3 times minus 4 will give you 12. So plus times minus is minus, and 3 times 4 is 12. Okay. Question number 7 says 4x cubed minus x squared minus 8x. Okay. All right. So we may choose to factorize generally or by grouping. So to factorize generally, we have 4. What is common? X seems to be common all through, okay? So since x is common all through, you write x as a common factor, because in terms of sign, positive, in terms of number, nothing is common all through. 4 can go here, 4 can go here, but it cannot, 4 can go here, 4 can go here, but it can't go here, so it's not common all through. It's only common to these two guys, okay? So we have this x, and then we can just take it all through. So we have 4x squared, because x divides x cubed to give us x squared, then minus, you know, x divides this one to give us ordinary x. I believe by this stage you know what I'm doing. X cut x tail, so we have minus 8. And so we have everything here. So this is an answer, all right? It's an answer. You can leave the answer this way, and then you can still further do quadratic equation, but that's going to be a matter for another time, because it's not within the scope of this particular video, okay? So I'm still going to treat this same topic in another video, but for something more complex, all right? So for this level of complexity, we'll just leave it this way. But there is still something we would have been able to do to go beyond these points. But that would be something we'll do in another class. Well, this question here can also be, we can also get our answer through a process called polynomials, okay? So, but that is also a topic for another class. I don't want to go into too many, as in so much advanced topics, when I have not taught you the things that will link you up to that topic, okay? So we just leave it that way. If you choose to factorize by grouping, okay, you can just take a group. So factorizing by grouping, we have Let's pick this one as 4x cubed minus x squared. Okay, then minus 8x. So when you take this group, factorization by grouping is not really so ideal in this sense because of the common factor x all through, but then it still works anyway. So group it. What is common in terms of sign? Positive. What is common in terms of number? Nothing. What is common in terms of number? 1, but it's invisible. Then what is common in terms of letters? X squared. So we have x squared, open the brackets, okay? So x squared goes in x cubed, okay? So we have 4x, then x squared goes in x squared, that's 1, all right? So we have minus 8x, okay, sorry, the minus 8x like this, okay? So what else can we do at this stage? Nothing, just strip it naked, remove the box, and then we have x x squared, we have 4x minus 1, then minus 8x. Okay, so it's not really looking cool. Then you can also group it the other way around and all that. But this particular kind of question has a way to further factorize it. But it is not going to be covered in this video because it is under another topic entirely called polynomial equations. But we are going to get there. Only called polynomials, so we're going to get there, all right, very soon. Wow, what a journey. And then we have done this so far. A bonus kind of question or something I just want to bring your notice to, okay, we could have some kind of cases. Let me just, let's consider this kind of case, for instance, a case where you have let's say we have minus 4x squared y, okay, plus 10x cubed y squared. So let's just make this like example 8, okay, just a bonus example. I want to stress a point here. That's why I created this. Okay, if you have something like this and you're meant to factorize it, how do you go about it? Well, in terms of signs, sign, number, letter, in terms of sign, minus is common, okay? Minus is common. Negative sign is common because it is the first term is negative. So we take it that way. So we have this minus here, and in terms of number, what is common? 4 can divide here, but 4 cannot go here. Okay, 2 can divide here. All right, but, and 2 can also divide here. So we have them as common factors, okay? We have that 2 as common factor. So we can take it, okay? 2 is common. All right. Then in terms of letters, what is common? In terms of letters, x is common, x squared, x is common here, but then something higher than x can also still go in the 2 terms, which is x squared. Okay, it is something beyond x squared that cannot work again, because by that time it's already more than this. So this cannot contain it anymore, but this can contain it, but this will not. So x squared is the highest that can go in both terms. All right, so no problem. So you have this, and then you have, in terms of another letter again, y can go here, y can also go here. Y squared goes here, but it doesn't go here because the highest y we have is y. So we write the highest y that we have. Okay, so we open the bracket and use this stuff to divide each of the terms here. So when you have minus 4 x squared y divided by minus 2x squared y, okay, minus divided by minus gives us positive, okay, then 2 here, 2, it remains 2, right? How many times can 2 go in 4? 2 times. Then we have x squared y divided by x squared y, so that is gone. Then the next one is plus 10x cubed y squared divided by minus 2x squared y, okay? Plus divided by minus, the answer is what? Minus, okay? And then 2 here, that's 5, okay? And then x squared will go in x cubed to remain only 1x. And then y go in y squared to remain only 1y. And so that is the final answer. All right? Okay, so one more of something that looks like this. Number 9. What if you have something like 8x minus 12 and you are meant to factorize it. 8x minus 12xy, and you are meant to factorize, okay? So what do you do in this case? Positive is common because the first number is positive, the first term is positive, no problem. So what is common again in terms of numbers? 2 can divide 8 and 2 can divide 12. But is that all? No. Something higher than 2 can still go in the two cases. Okay? Something higher than 2 can still go, which is 4. 4 can divide 8 and 4 can divide 12. All right? So, but then beyond 4, does any number occur that can divide both 8 and 12 beyond 4? No. We didn't use 2 because if you had used 2, the result we get will contain a bracket that still has a common term or a common factor. So we don't want to have a result that we still have. Okay, for instance, if I used 2, okay, then we'll be having, 2 and x, because x is common too, but y is not common. So we have 2x, x is the highest common factor for letters. So we have 2x, then we have 8x divided by 2x. Okay, x cancels x, 2 here, 1, and then this is 4. So we can have 4 here. And then minus 12x, y, okay, divided by 2x. Okay, so minus divided by plus is minus. Then here, we have 6. We have 6, x cancels x, so we have x. But this cannot be the final answer because even the bracket still contains contains 2 terms, okay, that's as common factor because 2 can go in 4 and 2 can still go in 6. So instead of having that kind of result, okay, it is forbidden, it is not proper to have a result in which the bracket still contains common factors. So when you have that kind of condition, in this case, you look for the highest common factor. So 2 is common, good, but also 4 is common. 4 can go here, 4 can go here. So we use the highest common factor, which is 4, in terms of numbers. But in terms of letter, x is common, okay? X can go in both sides, but nothing more. Then y can go here, but it cannot work here. So you open, then you use this common factor to divide each of the terms as 8x divided by 4x. So x cancels x. So we have 4 here, 1. 4 can go in 8 twice. So you have 2. Then we have 12xy minus 12xy divided by 4x, okay? Minus divided by plus is minus. Sorry, I shouldn't have done that earlier. So minus divided by plus is minus. Okay, so we have 4 here, and 4 in 12 is 3. X goes, so 3y. All right? And that is the answer. So at this stage now, you can see that nothing more is common within the brackets. And so we have our final answer. Okay, if you want to get this result back, just multiply. 4x times 2 will give you 8x. Then 4x times minus 3y. Plus times minus is minus. 4 times 3 is 12. X times y is xy. And that is that as per that. So I understand, I hope that we have learned a lot so far. Okay, if there is still any part of this that seems confusing, you can either just play back, and then just slow down and get it. If I'm too fast, there is you can always use the control buttons to reduce the speed of the video. Okay, and then you can reduce it by 1 to 0.5x or whatever. Okay, that is there, just to make it slower, and then you learn as well. Okay, so we have come to the end of this video, and we've learned a lot. I believe we've done a lot concerning factorization. So in the next video, we'll still continue with the same topic, factorization, but we'll be dealing with something a little bit higher than all of this that we have done. And that something involves quadratic expressions. So see you in there. Bye.